In this video, I'm going to show you how to solve a nonlinear system of equations when one of those equations is an absolute value equation and the other is quadratic. So when we solve any system of equations or two or more equations, we're looking for the points where they intersect or the ordered pairs that they have in common. And so I'm going to start by figuring out where f of x is equal to g of x by just setting them equal to each other. So I have x plus 3, or absolute value of x plus 3 is equal to x squared minus 4x minus 3. Now from here, I'm just going to solve this the way I would solve any absolute value equation, and to do that, I solve it as is without the absolute value bars. And then I'm going to solve it again. And you just have to make one of the sides negative. It doesn't matter which side you make negative. You just have to change the signs for one of the sides, because remember that if it was a basic equation like this, that x could be 3 or x could equal negative 3, because if you take the absolute value of either of those x values, you would still end up with a positive 3. So that's where this premise is coming from. And so I'm going to just go ahead and make the left side negative because that's a little bit easier. So I've got negative x minus 3 equals x squared minus 4x minus 3. So again, I only changed the signs of one side of the equation. All right, so I'm going to solve. I have a quadratic equation. So I'm going to set this equal to 0. Let me show this step instead of just assuming that you know what I'm doing. I'm going to take x away from both sides to get this to go away. I'm going to move this 3 over by subtracting it as well. And now I have my quadratic equal to 0 so that I can hopefully factor but use the quadratic formula worst case scenario. So I combined my like terms. Negative 4x take away x was negative 5x. And then negative 3 take away 3 more is negative 6. I'm going to factor. I do have another video on how to factor when a is 1 if you'd like to see it. My factors would be x minus 6 and x plus 1, because it needs to multiply to be negative 6 and add to be negative 5 in the middle. And so the two values that would make each factor 0 are x equals 6 and x equals negative 1. Now, unlike a typical absolute value equation, this is a system of equations. So I'm not just solving for x, I also want y. And so I'm going to plug back into either equation, f of x or g of x, to get that y value. When I look at f of x and g of x, I think that f of x is more simplistic, so I'm going to plug it into that one. So f of x is the absolute value of x plus 3. So to find y, I'm going to do the absolute value of x plus 3, the absolute value of x plus 3, and I just plugged what my x was in for x, and then also right there. So my first y value is the absolute value of 9, which is 9, and that ordered pair would be 6, 9. Over here, I would have the absolute value of negative 1 plus 3. Why did I put a parenthesis? Probably because I'm going too quick. That would be 2. And so my ordered pair would be negative 1, 2. Now this is a lengthy problem when you have absolute value with a quadratic, because you have to solve it both ways. So I'm going to go over here and do the same thing, but I'm going to use opposite operations. Plus x plus 3. These both cancel. I have 0 is equal to x squared. Take away 3x plus 0 now. So the negative 4x plus x gave me negative 3x, and then the negative 3 and the positive 3 made 0. I can still factor this, though. It usually trips people up when they see this, but you're just looking for a GCF. The GCF is x. They both have an x in there. Take it out. You'd be left with x minus 3. And so my two x values that would make my factors be 0 are just 0, because that x on the outside is by itself, so 0 times the parentheses would be 0, or 3, because 3 take away 3 is 0. Now, like I did in the left side equation, I've got to find the y value, so I'm going to still use the absolute value of x plus 3. The absolute value of x plus 3. I end up with 0 plus 3 is 3. The absolute value of 3 is 3. I have 3 plus 3 is 6. The absolute value of 6 is 6. And so my ordered pairs would be 0, 3, and 6, 0. Now, as if you didn't think that this was enough work, right? This is so much work for one problem. You have to check all absolute value equations for extraneous solutions. Extraneous solutions means you solved everything right, but when you plug it back in, it's actually not correct. It's not defined for that equation. And so what I'm going to do is I'm going to check it using Desmos. You could check by plugging the values back in. So what I've done is I have gone ahead and graphed f of x and g of x in Desmos to show you what it looks like. So there are my two equations, f of x and g of x, and I can see that absolute value, that v-shaped graph, and the parabola is the quadratic equation, the u-shape. And I'm going to click these two dots where they cross, -1, 2, and 6, 9. So this time, these are the only solutions that I'm going to highlight in green, and these are actually what we call extraneous.